Hello everybody and welcome back. So I have the data cached and I don't care too much about the VDB at this point for this example, and it looks like we did something wrong. Yeah, so I cached it as VDB. I put this down this node and I didn't change the type. When I cached it as VDB, it didn't work because the extension is wrong. It needs to be geo, or we have to make sure that this is VDB. But it's fine, we only need the points and it's still on disk, so I'm actually going to fix it right now. So I'm gonna do that because it's still on disk. I'll just hit save and should be super quick. But as I was saying, I don't need the smoke itself. Okay, so we have that just in case we wanted to visualize it. That's our sim, and I'm gonna use these two types. I'm gonna keep everything and just work with what I have. We have the velocity vector, and that's what I care about. I'm gonna delete all of this. I don't need it. I don't need this, and I don't need this. So I just need points on the first frame. That's all. But I don't want to use the sim or scatter new points. I want to use what I have stored, and I'm gonna use the first frame. Okay, so let's put down a time shift and use the first frame. I'm not gonna scatter new points. I'm just gonna jitter them a bit. 0.02, 0.01, 0.02, and change this every frame so it doesn't produce the same points. And let's dive inside. Actually, before we dive inside, I'm gonna take the points cached and let's take a look at them. So this is the points. So this is the cache data, and you can see it's following the same movements. Okay, there's some issues with the sparse. Obviously, it's clipping some stuff, so maybe we turn it off, but for now it's gonna be fine. Now this example here, this data is not gonna work. This is not a particle sim. Okay, it's not going to work if we use it as sparks. You could try, but it doesn't have all the characteristics that we need, and the points are changing every frame. So every frame the points are completely new set. They have no connection between the previous frame. And this is what I prefer doing. Okay, so I'm gonna connect that and I'm gonna dive inside. And let's use all points, that's fine. If we hit play, it's working. And the first frame has velocity. And I don't need this effect by volume. And I think we have a lot of points, so what I'm gonna do is delete 10% of them. I'm gonna put down a, keep 10% so it's faster. If random of $pt is less than 0.1, higher than 0.1, I want to delete the points. Remove 0.0 at ptnum. So we have we have 10%, and this is going to be faster to work with. Now that's the initial velocity. I'm not going to add anything to it. I'm just going to say use what's coming from the sim, okay, which is not that much because the first frame doesn't have enough movements. So maybe we'll pick a different frame. Yeah, maybe we'll pick this frame 5. And now we have something going. Okay, let's dive inside. I'm gonna create a point VOP, a pop VOP. And I'm gonna go to the inputs and set these to match first, second, third, and fourth. And we can change this to be the default because I always have to do that. So save as permanent default. And now every time we create this VOP pop VOP, it's gonna have the inputs like that. Okay, so what do we need? Well, we need to do a point cloud lookup on the second input and tell these points to go find the nearest point from that from that set, query the velocity, and then plug it in and use it. So let's put down a point cloud lookup, point cloud open. It's the second input, and the point position is this. I'm going to use a big radius of 1 and 25 points. And now it's giving us back a handle. I'm going to use a filter, point cloud filter. It expects a handle and then the channel that we want to read, which is velocity. And I'm simply going to plug this in. Okay, I'm not going to do anything. I'm going to just do this and hit play. And it's doing something. You know, it's doing something interesting already. But it's not, it's querying the data from the points and it's not keeping anything current, if that makes sense, because we're overriding it every frame and yet it still works. So that's how good this solution is. We already get something really, really, really nice with just one node, and it's very, very fast. Now what I'm going to do is I'm going to add this velocity onto the existing one. Okay, so let's hit play. Now if we do this, we're going to get this explosion. The reason for that is because we're continuously adding the velocity over and over and over and over, and I don't want that. We need to keep the same velocity magnitude over time. And what we want to do is we want to simply change the direction of the velocity. Okay, so what I'm going to do is I'm going to put down a length attribute and compute the length of the velocity. And this is going to help me maintain my velocity over time. So if I mess up, if I change the velocity, I'm only going to change its direction, not its magnitude, unless I wanted to. But with this idea, we're going to take the current velocity, we're going to add some velocity to it, we're going to normalize that to make sure that it gets back to 1, and then we're going to multiply it by the magnitude. And I think it's better if I draw this. And let's do the sketchboard. And my awesome drawing with the mouse. And let's say we have a point and it has a velocity of a vector like this. It has a magnitude of 10. If we keep adding values to this, the next frame is going to be, let's say we're adding a velocity or a new vector that is oriented like this, and this is my y-axis. Okay, this velocity is going to move somewhat like this. Okay, but now with the magnitude, it's going to be like this, because it takes this orientation and it combine both of them, so it's going to push it. So it's longer, and what we need to do is we need to do the addition of these two to get this new orientation and then normalize it, which means, so let's say this is my new vector and this is my current vector. If I add both of them, they're going to be like this. Okay, what we need to do is we need to normalize this, and that's going to give us a new vector that's equal the length of 1. Let's say this 1 unit. Okay, to restore the correct magnitude, we're going to take the original velocity vector, compute its length, and that's going to give us a float, a scalar. So the length of this is 10, which is the magnitude or the speed. We use this value to multiply this unit, and that way we change the direction of the vector, we normalize it, and then multiply it by the original magnitude of the incoming velocity. This way we don't change the magnitude over time. So I'm going to normalize everything after adding it, and then we multiply this, and I'm going to switch the inputs because vector first and then scalar. And if we hit play now, it's going to be much more stable. Okay, you see it's already calm with inside the sim. But I'd like the what we've seen before. I like how it's looking. So what I'm going to do is I'm going to add a multiplier here, and let's promote this, and let's set this to 1.5, and let's hit play. So at this point it's not going to do much to this, and what we need to do is we need to multiply, add a small multiplier here, and that's gonna make sure that we are still, apart from normalizing it, we're still adding some values to it. Okay, I think it's too much, so say 1.05, something like that. And then what we can do is we can also mix all of this with the first idea that we did. So I'm gonna mix this velocity, which has different orientation, with the one coming directly from the sim, and my result is going to be a combination of both, and that way we keep the information in the sim going, but also make sure that we inherit from the velocity, and this way we're going to keep both of them combined. Okay, and I'm going to set this to 1. I don't need to multiply it after. And we have our Sparks system working. Okay, so that's the main idea for this. We can obviously start working and making things a bit more interesting. So we have this point position. What we can do is we can create a noise pattern, and let's export the frequency, amplitude, offset. And I'm gonna add this to the point position. Remember, we're not changing the point position itself, we're simply changing it when we do the lookup. So instead of this point querying the velocity that is exactly next to it, we're going to shift it a bit, and this is gonna help us add some breakups. So let's try a value of 10, and that's quite strong. You see the result is very far off. Let's try a value of 1. And it's adding breakups already. Okay, so that's pretty much it for getting the advection going. The idea is we want to query store this data and then use it to advect the points. Now, we also are doing a few other things. Remember, we have that velocity, the temperature attribute and the flame attribute cached. I also want to always update those inside the sim. So I'm going to use a second filter, PC filter. I'm going to look up for the flame attribute and the temperature attribute. And I'm going to set them to float and just bind export this. I don't need to advect this over time, it's fine. Temperature. Okay, let's go back up. I'm going to go back up one more time, create a DOP import. Drag this here, and we want to import the pop object, and we want to fetch the geometry. So if we hit play, we get our points, and if we middle click, we should see temperature, a type. No, the type is fine. It's not working at the moment because we didn't copy it. It's only coming from the source geo. So let's do a color node and say ramp from attribute. Try the ramp, the flame attribute. Perfect. So we have a flame that we have this information that we can use, but right now we have both the temperature and the flame. So let's go with the temperature, because the temperature is going to cover pretty much everything. And I'm going to say it's between 0 and 0.5, and let's use an interesting tone. something like that, something like that, and here I'm gonna give it a dark red tone. Now if we hit play, we get some really nice coloring going, and this is inherited from the flame. So whenever it's gonna get bright, we're gonna get this coloration, and whenever it's gonna be dark, it's gonna match, which could be really useful. But in some cases, we may want to have the sparks always bright, you know, super bright, and then much brighter when there is a flame. Okay, so I'm gonna do let's do pixels, yeah, and let's check the number of points. It's fine. Gonna increase the cache here, 20 gigabytes. I'm gonna turn the point count a bit higher, so 5%, 50%. I'm gonna do a quick sim just to show you guys the amount of details we can get with this simple solution. So let's hit play, and then we'll continue in the next video. Thank you guys for watching, and see you in a bit.